All right, folks, welcome to section 5.3. This will be parallel lines and transversals. However, let's start again, as usual, with a quick recap of the last lesson, 5.2, which was on bisectors and perpendicular lines. So let's take a look at the first question. And once again, as usual, I'll invite you to pause your recording, try out these questions for yourself, and then resume it once you think you have the answers, and we'll work through it. Okay, so we've got an angle that is bisected. The resulting angles are 42 degrees each. Determine the measure of the original angle. So once again, bisection means that an angle was cut in half. So if we start with some angle here, let's erase this a little bit so I can move this one down. We start with some angle here. Don't know how big it is. When we bisect it, we cut it in half with another ray. Then the resulting angles are 42 degrees each. 42 degrees and 42 degrees. So what was this full angle that we started with? Well, it's simply going to be 42 plus 42. 84 degrees. When you bisect 84 degrees, meaning you cut it into two equal parts, sectum sempra, 42 degrees and 42 degrees. Right, so 84 is your answer for this first question. Second question. A 156 degree angle is bisected. What does 156 look like? 156 degrees, obviously that's an obtuse angle. And one of the ways that we can draw it and figure out how big it is exactly is to subtract it from 180. So we get 24 degrees left over. Right, 156 plus 24. So an 186 degree angle, if we have a 24 degree angle over here, then this is going to be 156 degrees. I just like to draw diagrams. You don't actually have to do that for this question. When you are bisecting an angle, you're cutting that angle in half. And when you cut 156 degrees in half, you get 156 degrees divided by 2 equals 78 degrees. Okay, so that's what happens when you bisect a 156 degree angle. You get two 78 degree angles. This is 78 degrees, and this is 78 degrees. Okay, so that's our quick review. Let's move on to section 5.3. In section 5.3, we're going to look at non-parallel lines. And there's a lot of information coming up. I'm going to try to color code it as best I can, and I would recommend that you do the same in your workbooks. This is what has helped the most for students, is to take a look and color code, highlight things in your workbook so that you can reference back to it later. This is on page 231. When you're doing your quiz for this unit or for this section, make sure you go back to page 231. Use this as a reference. You can. It's an assignment, so get as many marks as you can. You don't have to memorize all this stuff because it's there for you. Okay, corresponding angles. Two angles that occupy the same relative position at two different intersections. So corresponding angles are two angles that occupy the same position at two different locations. So for instance, 2 and 6 are corresponding. Oh, sorry, I should do that with the same color as I have up here. So let's do corresponding angles in green. Same position, different intersections. Vertically opposite angles are angles created by intersecting lines that share only a vertex. So these are in an intersection, like this is one intersection, this is a second intersection. And vertically opposite angles are those that share only a vertex. So for instance, 5 and 7 are vertically opposite angles. They are across from each other in an intersection. The only point where they connect is at that vertex. So they're the ones that are diagonally opposite. We call that vertically opposite. They always have the same angle measure as each other. Always. So 5 and 7, no matter what angle this is at, those are always going to be the same. As you rotate this line around, 7 would get bigger, 5 would get bigger at the same pace. They're always going to be the same. Similarly, 2 and 4, 1 and 3, etc. Okay, let's look at the next one. Alternate interior angles. Let's do this one in black. Alternate interior angles. So these are angles in opposite positions between two lines intersected by a transversal. We have two lines intersected by a transversal. Alternate interior. So we've got one here. That's an interior angle. And we're going to alternate. We're going to flip to the other side of the line. So 3 and 5 are alternate interior angles. Actually, let's go back and write this in. 5 and 7 here. And green for the first one, so 2 and 6 are examples. There's more examples for all of these. I'm just doing one example of each. And the last thing we're going to look at is alternate exterior angles. If alternate interior ones are the ones that are in between these two lines, alternating sides, then alternate exterior are going to be the ones that are outside those two lines. One's on this side of the transversal, one's on this side of the transversal. So 2 and 8 are two examples of alternate exterior angles. So the next thing we get to is page 232. In the following diagram, we're going to identify each of the following, specifying which lines and transversals we are using. So we want to identify in A, an interior angle on the same side of the transversal as 6, angle 6. So angle 6, I'm going to start by identifying that, is right here. We can consider two different transversals. We could consider this transversal, or we could consider this transversal, right? Because 6 is attached to both of those lines. One of those is going to be the transversal. So let's start with looking at L1 as my transversal. An interior angle on the same side of the transversal as 6. Well, 8 would be an interior on the same side of the transversal. But perhaps I think what this is looking for is considering L3, my transversal, because then 6 and 2 are both interior angles. Right? Otherwise, 6 is an exterior angle on this transversal. It's not on this transversal at all. We can't consider L2 to be one. It's not on L4. It's not on that transversal. So 6 and 2 are my best answers there. But an angle corresponding to 2. So corresponding means it's in the same part of the intersection. Which part of the intersection is? It's above and to the left. So in question 2, we're looking for something on the same side as 2. 4 is corresponding. We also have number 1, which is corresponding because it's on the same line. It's also above the line and to the left of the line, so the sort of the northwest quadrant, if you want to call it that. We could even look at 3 if L2 is my transversal and I'm looking at L1, not 3. So all of those would be corresponding to 2. And finally, angles corresponding to 4. Well, obviously, if if 4 corresponds to 2, then 2 also corresponds to 4. 3 also corresponds. Maybe I should go blue this time, sorry. 2 also corresponds. And 7 also corresponds to 4, right? This is the one I'm starting with. This part is upper left, this part is upper left, this part is upper left. 1 doesn't correspond because it's not on that same line. Finally, we're going to get to an alternate interior angle to angle 4. Angle 4 is here. So we have, this has to be an interior angle. It is an interior angle along this transversal. So here would be an alternate interior, but we don't have a number there. Can't be that one. The only other place it could be is right here. 9 is my alternate interior angle. We consider the transversal to be L2, then 4 and 9 are alternating interior angles. I hope this makes sense to you guys. So we've learned a bunch of new terminology. Corresponding angles, they're in the same position. Vertically opposite angles are across from each other in a single intersection. Alternate interior angles, they are between 2 lines that are crossed by a transversal, and they're between them, right? So that means interior, between, because it's within those 2 lines, and on opposite sides or alternating sides of that line. 6 and 4 would also work, 3 or 5. And then alternate exterior, outside of those 2 lines, and on alternating sides. Okay. More stuff. All right, page 234, this is the example. In the diagram below, measure and record the sizes of angles. Identify pairs of equal angles and state why they are equal. Well, first off, let's talk about, well, no, let's measure as it requests. We're going to take our protractor. Let's make it bigger so we can see it. Let's rotate it slightly and move it. The middle's there. All right, so angle number 1. We can see it goes halfway between the 50 and the 60, or more accurately, the 120 and the 130. So that's about 125, maybe 126. We're going to call that 125 degrees. Okay. Angle, well, I'm going to cheat a little bit here. I know that vertically opposite angles are always the same. So rather than immediately like remeasure this, which I could do, flip this around. Obviously it wasn't quite centered, or that would have stayed. And we also have 125, maybe it's closer to 126 or 127. 3 is the same. I'll call it 126 degrees. That seems to be more close to what it is. All right, so 3 and 1 are the same. What's 4? Well, I can see 4 here as well. This is 53 degrees. I should write it as 53, hey, shouldn't I? That's clearly what it's showing right now. And if I want to also measure angle 2, goes back here. And oh yeah, I took an estimate because my line didn't go far enough. So that's also going to be 53 degrees. And taking a look at these numbers, obviously I'm a little bit off because 3 and 4 should be supplementary and should add to 180. When I saw it was 126 or 127. Let's call it 127 degrees because as I rotated, I saw that my first measurement was a little off. Okay, so 1, 2, 3, and 4. What about on the bottom here? See if this lined up a little better. Okay. Oops. Okay, that looks pretty good. What is my angle 6? Angle 6 looks like it's right on 60 degrees. Its vertically opposite side is 8. Angle, 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 just to make it clear that these are all angles I'm measuring. Angle 7 then, which is, as you can see, is supplementary to angle 6. Well, let's go with 5 first because I can actually see it on here as well.
Mr. McLeod, will you please come to the main office? Mr. McLeod, please come to the main office.
70's got to be the same. So, yeah, straight angles are formed by any two supplementary angles. So 6 and 7 are supplementary, 7 and 8 are supplementary, 5 and 8 are supplementary, 5 and 6 are supplementary. Those are all supplementary. And vertically opposite angles are always equal, 6 and 8, 5 and 7, 1 and 3, 2 and 4. So by measuring it, we can tell that. And those are rules. Those are going to be true all the time. Vertically opposite angles are always, if within one intersection, are always equal to each other. And along the straight angle, we always have supplementary angles that add up to 180. That's it for today's lesson. Pretty simple, except there's a bunch of new terminology, so I do encourage you to use your workbooks, work through some of that technology, get familiar with it, get accustomed to it, check your answers with the back to make sure you've got it, and I will see you for the next lesson, 5.4.